Really cool. So today we're doing 5-3, the binomial theorem. We already know how to do this by hand. So remember, binomial means two terms, correct? Binomial means two terms. When we have two terms raised to any degree, we know that it would be breaking the forbidden rule to just do x cubed plus 2 cubed. That's the forbidden rule. We know we have to rewrite it as x plus 2 times x plus 2 times x plus 2. And we know how to multiply that out. We're not going to do that, however, but we would multiply these two together. We would combine like terms. And then we would distribute all that stuff into x plus 2, combine like terms. That one's not bad to do. Only raised to the third power still takes a lot of work, but we could do it. But let's say we have polynomials to a very high degree, then this would become, like I call it, a daunting task. X plus 2 to the 12th power would take us forever, like hours. You would take your whole ACT just to get that problem wrong because you made one error. You know what I mean? So what we're learning today is going to help us with stuff like that. Okay, there's a couple things you have to notice, some patterns here. So everybody look, we're going to look at some binomials raised to the 0, first, second, third, and fourth power. And let's notice a couple things. So x plus y to the 0 power is 1. Any base raised to the 0 power is 1, correct? X plus y to the first will be x plus y. X plus y squared equals x squared plus 2xy plus y squared. X plus y cubed equals x cubed plus 3x squared y plus 3xy squared plus y cubed. X plus y to the fourth is x to the fourth plus 4x cubed y plus 6x squared y squared plus 4xy cubed plus plus y to the fourth. So a couple of things to notice. If I call degree n, if we have a binomial of degree n, notice we have n plus 1 terms. One more than the degree. One more term than the degree. So look, degree 0 has 1 term, correct? Degree 1 has 2 terms. Degree 2 has 3 terms. Degree 3 has 4 terms. Degree 4 has 1, 2, 3, 4, 5 terms. So a degree 5 would have how many terms? So a degree 20 would have how many terms? 21. Good. Okay, so that's a pattern we will use. The powers of x decrease as the powers of y increase. So I'm going to show you that. I'm going to say that again. Powers of x are decreasing on each term as powers of y increase. Look right here. X squared, x to the first, x to the 0. Does everybody see that? How x was decreasing. X cubed started with the highest degree, then x squared, x to the first, x to the 0. Does everybody see how x is decreasing? X to the fourth, third, second, first, x to the 0. And then our powers of y are increasing. Look right back up here. Y to the 0, y to the first, y to the second. Y to the 0, y to the first, y to the second, y to the third. Y to the 0, y to the first, second, third, fourth. Does everybody see? So powers of x are decreasing, powers of y are increasing. That's a pattern we're going to notice and use. The degree of each term is n. The degree of each term is n. So this is what I mean by that. I'm going to use a highlighter here. So if this is degree 1, do you see how this term has degree 1, degree 1? This is degree 2. This has degree 2. 1 and 1 is still degree 2. Degree 2. Do you see how all the terms have degree 2 here? 1 and 1 multiplied together would be 2. Okay, 3, degree 3, look, degree 3, degree 3, degree 3. Degree 4 is degree 4, degree 4, degree 4, degree 4, degree 4. So the degree of each term will be the same as this degree. And then coefficients increase and then decrease in a symmetrical pattern. So remember what a coefficient is. A coefficient is a number in front of the variable. So everybody look. 1, 2, back down to 1. You see how it was symmetric? It went up and back down. 1, 2, 1. Now watch. 1, 3, 3, 1. It's going up and back down in a symmetric pattern. 1, 4, 6, 4, 1. Everybody's seeing that. The coefficient, the number in front of the variable, is going up and then down in a symmetric pattern. So I had somebody last hour say, well, how do you know what numbers those are? And that's what brings us to the next thing. So coefficients are the number in front of the variable. We're talking about binomials, 2 terms. So the coefficients of a binomial expansion are called binomial coefficients. To find them, you can use the binomial theorem, which is the highlighted thing. So write down the binomial theorem. This theorem will enable us to find the coefficients, the number in front of the variables. So NCR is a probability and statistics thing you learned in secondary math too. So it's read as N choose R. And that's the number of ways you can choose R in a group of N. So it's this formula, N factorial divided by N minus R factorial times R factorial. That'll give us the coefficient, the number in front of the variable of X raised to the N minus R times Y to the R. Okay, now some notation. You could see it written as NCR, or you could see it written like this. So they're equal. They're just written differently. So this means the same thing as this. So if you see this, you'll use this formula. They just mean the same thing, it's just written out differently. So that was what that was. Okay, so let's say we are looking at X plus Y to the 7th. 7 choose 3 would be the coefficient in front of this variable. So 7 choose 3, so this is NCR. So X to the N minus R would be X to the 7 minus 3, which is 4, correct? And then Y to the R, so Y to the 3rd. That would be, if we actually calculate 7 choose 3, we'd be finding the coefficient in front of this particular variable. Now we're going to get into where those will sit in a second, so don't worry about that. You're like, well, where is that in that long expanded out thing? We're going to get there. So just all I want you to focus on right now is this next piece. Okay, so one thing to note is this. 7 choose 3 is actually equal to 7 choose 4. So what I'm saying by that is NCR will be equal to NCN minus R. So I'm going to say that again. You'll maybe want to write that down. These will literally be equal, and we'll go through and I'll show you mathematically why that is. So 7 choose 3 equals 7 choose 7 minus 3, which is 4. Does everybody see how what that formula, or like this statement is this? Everybody good with that? Okay, let's go through and calculate these using algebra. So let's do 7 choose 3 using our formula. So that would be 7 factorial divided by N minus R. So that would be 7 minus 3 factorial times R factorial. So times 3 factorial. So over here, this is 7 choose 4. So that's 7 factorial divided by 7 minus 4 factorial times by 4 factorial. Let's simplify this again. I'm going to scroll up and give some people in the back some room to see. So this piece right here is really 7 factorial divided by, what's 7 minus 3? 4 factorial times 3 factorial. Now over here on this side, that's 7 factorial divided by 3 factorial for this piece times 4 factorial. Now look, mathematically, isn't that the exact same thing? That's why they're equal. So let's simplify this side, and then we'll talk. So 7 factorial means 7 times 6 times 5 times 4 times 3 times 2 times 1. 4 factorial would be 4 times 3 times 2 times 1, and then times 3 factorial, 3 times 2 times 1. Let's start dividing some of these things out here. 4, 3, 2, 1. 4, 4, 3, 3, 2, 2, 1, 1. Yeah? Those divide out. Now left is 7, 6, 5, and then on bottom 3, 2, 1. 6 and 2, or 6 and 3 even, right? 6 and 3 become 2 over 1. Now look, 2 and 2 divide out, right? And then that's it. So left over was 7 times 5, which is 35, over 1, which is 35. I'm going to show you mathematically how to easier do that. Even though we know this side's going to be 35, look at my thought process behind how I'm going to simplify this a little bit quicker. So this side, 7 factorial is this. 7 times 6 times 5 times 4 factorial, true? Divided by 4 factorial, 3 factorial. So don't the 4 factorials divide out? I'm going to have to write it all out. And then 3 factorial is 3 times 2 times 1. So we do have, then we would continue this. But if you can ever be smart about simplifying, you would want to be. Does that make sense, everybody? So we could keep going. We know we're going to get 35. Okay, sweet. So this is how it works. So, first of all, if I said to you, what's x plus y to the fifth, what would your answer be if I said, how many terms, when we multiply this out, is it going to have? 6. Good. So, we're going to have 1, 2, 3, 4, 5, 6 terms. Now, it's degree 5. So, you're going to start with 5, choose 0. Then you're going to count up. 5, choose 1. 5, choose 2. 5, choose 3. 5, choose 4. And 5, choose 5. Using the binomial theorem here to get the coefficients in front of the variable. So I just counted up. Everybody good with that? Okay. Now don't we know that one little rule I just talked about, NCR is going to be equal to NCN minus R. So let's do this. 5 choose 0. Isn't this going to be the same as 5 choose 5 minus 0? What's 5 minus 0? 5. So this will be the same as 5 choose 5. So we don't want to have to calculate them both. If we know 5 choose 0, we know 5 choose 5. Everybody good with that? Okay, 5 choose 1. What's 5 minus 1? 4. So this will be the same as 5 choose 4. 5 choose 2. What's 5 minus 2? 3. So 5 choose 2 is going to be the same as 5 choose 3. So look, it's going in an even pattern here. That's why. So let's go ahead and calculate these first 3, and then we'll know the end 3. So let's use algebra. 5 choose 0 is 5 factorial using our formula for NCR over 5 minus 0 factorial, which is 5 factorial, and then times R factorial, so 0 factorial. So 5 factorial and 5 factorial become a 1 over 1. 0 factorial is like a 0 degree of 1. So what's the coefficient here? 1. Okay, I'm going to write that down here. So this is coefficient 1. So we know that this coefficient must be 1. Everybody good with that? Let's do the math for the next one here, the next coefficient. 5 choose 1. 5 factorial divided by 5 minus 1 factorial, 4 factorial times 1 factorial, which is just 1. Can I not write it? Does anyone do math? Yeah. You want me to write it? Okay, well, you were confusing. Okay, so we have 5 times 4 factorial on top, correct? Yeah? And then on bottom we have 4 factorial times 1. So don't those 4 factorials divide out? So this is 5, so then this coefficient must be also 5. And we're almost there. 5 choose 2, 5 factorial divided by 5 minus 2 factorial times 2 factorial, which we know this is 5 times 4 times 3 factorial on top, and on bottom we have 3 factorial times 2 factorial. 3 factorials divide out. 4 divided by 2 times 1. 2 times 1 is 2 factorial, like I said. 4 divided by 2 is 1 over 2, so we get a 10. Well, if this is 10, then this is a 10. We just found the coefficients in front of our 5 terms. Everybody good with that? Yes. Now let's put in the, just for kicks and giggles, let's put in the x and the y. This part's easy. Won't the front thing count up? The degrees count down. Remember the pattern? And the other one will count up. So we'll start with the highest degree, which is 5. So x to the 5th, x to the 4th, x to the 3rd, x to the 4th, x to the 3rd. Wait, what the heck? Sorry, going nuts up here. Okay. Sorry. 5, 4, 3, 2, 1, x to the 0. And y's will count up. Y to the 0, y to the 1st, y 2nd, y 3rd, y 4th, y 5th. Now check a couple things. Wasn't our original degree 5? Degree 5, they all better be 5 or you messed up somewhere. Degree 5, degree 5, degree 5. Okay, now we can start simplifying here, yes. So 1x to the 5th, y to the 0, that's a 1, so that's x to the 5th. 5, so we'll have plus 5x 4th y plus 10x cubed y squared plus 10x squared y cubed plus 5x y to the 4th, and then plus y to the 5th, right? Any base of 0 powers 1. You see how that was actually much quicker than multiplying out 5 of those. It really is. And it gets faster. Okay, try this one. What are the coefficients of a plus b to the 4th using the binomial theorem? So what was our first step? We said how many terms will we have? 1, 2, 3, 4, 5. There's n plus 1 terms. So what would we start with? 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, and so on. Ready, set, go. We were all able to get to the coefficients being 1, 4, 6, 4, 1, yeah? Those are the coefficients, that's all I asked, but we could go through and put in our powers of a if we wanted really quickly. A to the fourth, a to the third, a to the second, a to the first, a to the 0, so I'm not going to write it. B to the 0, b to the first, b to the second, b to the third, b to the fourth, and then they were all addition. They're all positive. Okay, now that was way quicker than multiplying out to the degree 4. So you should be using this in your future from here on out when you can. Think of how much time that saved me on the ACT. Tons of time, right? Time is money on the ACT. So you would use this method. Okay, so couple things, guys. These are just some examples of a plus b to 0 once again. Here's the expanded form, and here are the coefficients only. Everybody look at it. You see how it's making like this triangle type thing? Okay, so I'm going to read this to you because I can read it out of my book better than I can just say it in words because it just sounds better when I read it. So, everybody listen. There's a convenient way to remember the pattern for binomial coefficients. By arranging the coefficients in a triangular pattern, you obtain the following array, which is called Pascal's Triangle. Okay, so it says the first and last terms in each row of Pascal's triangles are 1. Everybody look at the picture over here of the coefficients. So the first and last numbers in each row of Pascal's triangle are 1. Every other number in each row is formed by adding the two numbers immediately above the number. Pascal noticed that the numbers in the triangle are precisely the same numbers that are the coefficients of binomial expansion. So instead of using the binomial theorem, we're going to be able to use Pascal's triangle because it is the binomial theorem but already done out for us. Does that make sense, everybody? Not having to go through and do 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. This will be much quicker. So here's Pascal's triangle. I'm going to show you how to create it by hand. On the test, you will have to create it by hand. It's really easy. You will not want to memorize this, and it keeps going. So on your ACT, you'll want to be able to reproduce this. Everybody, it's really quite easy. This is how you do it. So we start out with 1 on top. Now, the ends are always 1. Now you add up the ones above it. So the next row will have a 1 and a 1. What's 1 plus 1? 2. Does everybody see how I got that? So look, there's 1, 2 terms, 3 terms. The next one will be 4 terms. I put my 1s in. 1 plus 2 is 3. 2 plus 1 is 3. Now we put 1s on the diagonal. 1 plus 3 is 4. 3 plus 3 is 3 plus 1 is, and we continue this pattern. 5, 10, 10, 5, 1. Does everybody see how I can keep going forever? I can keep going, okay? So I have it written out so that we can go through this quickly. So I'm going to erase this real quick. Does everybody see how I can keep adding and going? Okay. Okay, so now everybody, this is where people mess it up. You've got to remember that the top one is degree 0. Any base to the 0 power is 1, and then anything raised to the 0 power, if it's a binomial, will have 1 term. So this will be degree 1, degree 2, degree 3, degree 4, degree 5, coefficients in front of 5, degree 5, 6, 7, 8, 9, degree 10, and we could keep going, because if on the ACT they say 12, you'll want to keep going. Does that make sense, everybody? Okay. All right, so these will be our coefficients we're going to use instead of doing 4 choose 0, 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4. All right, so do we have that written? You're going to want Pascal's triangle, write it down, take a picture or something, but you'll have to be able to reproduce it yourself on the test and stuff. So we don't want to have to write at every problem. So do we all have that at least written somewhere? So I need to give you a second. So let's do number 1 using Pascal's triangle. It's degree 4. So look at your triangle. What are our coefficients? 1, 4. You're going to leave yourself plenty of room. 6, 4, and 1. Leave yourself plenty of room. Our front thing is x, so we'll have x to the 4th. It's going to count down. x cubed, x squared, x to the first, x to the 0. Any questions so far? Our backswing is going to count up. So that'll be 2 to the 0. I don't need to write that, right? 2 to the first, 2 to the second, 2 to the third, 2 to the fourth. Now, those are all positive. Well, we'll see. I mean, they are all positive. So let's now simplify. So we have an x to the fourth. Now we have 4 times 2 to the first, which is 4 times 2, which is, so we have our 8x cubed. And then we have plus 2 squared is 4 times 6 is 24x squared. And then we have plus 2 to the third is 8. 8 times 4 is 32x. And then 2 to the fourth is positive 16. Holy cow, that was way quicker than multiplying that out by hand.
Oh, yeah.
How cool is that? It's way cool. Okay, let's do another one. Number 2. 8 plus 2 to the 7. So find a row, so 7. I'm going to split this one up. So we have 1, or do you guys want to go for it?
We'll go for it.
You'll go for it? Okay. Okay, so up here. What time do we get out? Okay. Oh, still. Okay. Everybody watch with the negative. I changed number 4 to degree 5 so it's not so big, but you can get the picture of how to do this. So everybody, degree 5's coefficients are 1, 5, 10, 10, 5, 1. Okay, here we go. Everybody watch because there's some interesting stuff. Our front thing will be d to the 5th, d4, d3, d2, d1, d to the 0, correct? Now careful, this is a negative 2, so we're going to have negative 2 to the 0, so I'm not going to write it. Negative 2 to the first, negative 2 squared, negative 2 cubed, and negative 2 to the 4. Okay, so think about it, guys. Won't all the even degrees make the negative positive? So isn't this going to bounce between positive and negative signs? Okay, so let's just make sure that happens. So simplifying. Positive d to the 5th. Negative 2 to the first is negative 2. Negative 2 times 5 is negative 10. Negative 10 d to the 4th. Everybody good? Negative 2 squared is positive 4. 4 times 10 is positive 40. Negative 2 cubed is negative 8. Negative 8 times 10 is negative 80. What do you mean? Oh, should have been d. Oh, this is negative 2. Sorry, I squished them together. And this is negative 2 to the 5th. Okay, that makes better sense. What's negative 2 to the 4th? Positive 16. What's 16 times 5? Calculators, guys. We gotta go way quicker. Yep, positive 80. And that was d to the first. And then negative 2 to the 5th is negative. Yep. So notice, positive, negative, positive, negative, positive, negative. All good here. All golden. Everybody feeling good? Okay? Do you feel like we need to do this one with a 2 on an x and a negative 3, or is it the same? It's the same idea. Everybody good with the same idea here? Or yeah, so the 2, it'll be 2x to the 4th, 2x to the 3rd. So you'll have to distribute and raise it to the power, the 2 also to the power. Do you get what I'm saying, everybody? Okay, and then let's do one with an I. Oh, in a second. Okay, listen up. This is more likely what you'll see on an ACT. It'll say this. Find the third term of x plus 3 to the 10th. So we would not want to go through the whole thing, would we? That would be a nightmare. Everybody find x to the 10th. What's that third term in coefficient going to be? Look at Pascal's Triangle. 45. Does everybody see what I'm saying? So we're going to write 45. Now think about it. The front thing will start out x to the 10th. So look at your triangle. The first one will be x to the 10, then x to the 9, x to the 8. Okay, are we all good with that? And then 3 will be going up. So 3 to the 0, 3 to the 1, 3 to the 0, 1, 3 squared. So now simplify that. What's 45 times 9?
405.
So you would say 405x to the 8th. That's more likely what you would see on an ACT. Everybody good? Okay, let's do this one. Here we go. Everybody pay attention. There's something like this on the online homework. So you would say, I don't want to have to multiply this out by hand. I know it's a binomial, so I'm going to use Pascal's Triangle. So find degree 4. Our coefficients will be 1, 4. I'm going to spread them out. 6, 4, and then I'm going to put the 1 down here. Now the front thing is 4. So 4 to the 4th, 4 to the 3rd, 4 to 2, 4 to the 1st, and 4 to the 0. Just for kicks and giggles, I'm showing my work. And then we'll have 2i to the 0, 2i to the 0, 2i to the 1st, 2i squared, 2i cubed, 2i to the 4th. Okay, now let's continue to simplify this. Any base to the 0 power is 1. 4 to the 4th is, okay, so we have 256. That was for this piece. Now careful, let's look at this piece. 2 to the 1st is 2, I to the 1st is I. So we have 4 times 4 to the 3rd is? 4 times 4 to the 3rd. Yep, it is 4 to the 4th, and then times 2. 512. So we have plus 512, and that was positive. So plus 512i. Questions on where I got that? Okay, moving on. So careful right here. This is 2 squared and I squared. So 2 squared is? 2 squared is 4. So this is 2 squared I squared. So that's 4 times negative 1, yeah? So negative 4 times 4 squared times 6. Negative 384, sweet. We just did that piece. Now be very careful right here. We have 2 to the 3rd, I to the 3rd. Well, you got to think I to the 3rd is the same thing as I squared times I to the 1st, yeah? So isn't that negative 1 times I? So this is really negative I. So negative 8i, right? Negative 1 times 8 is negative 8, and then we have our I. Okay, so then 4 times 4 times 8, negative 8. 4 times 4 times negative 8. Negative 128i. And then we're almost done. Now let's do this piece here. 4 to the 0 is 1, and then we have 2 to the 4th, I to the 4th. You've got to think of, anytime you have i's on ACT, anything, you've got to think of it in squared. So I to the 4th is I squared times I squared, which is negative 1 times negative 1, which is positive 1. So that becomes a 1. 2 to the 4th is 16 times 1. So we have plus 16. Now, this is a complex number, a plus bi. You can combine real parts with real parts, imaginary with imaginary. So take your calculator. 256 minus 384 plus 16. Negative 76. 512i. I'm just bleeding you. This is not 76? Okay, let's just fix it real quick. What is it? Okay, negative 112. Okay, perfect. And then how many i's? Positive 512i's minus 128i's. Negative or positive? Positive 384i's. Now, if you type this into your calculator wrong, if you type it into your computer wrong on Math Excel, it'll say, you have the right answer, but in the wrong form. Because don't we write complex numbers as a plus bi? So we need to write the imaginary one second. Everybody good with that? We all understand how to do this on the online homework. Okay. So, now that you have a second, do a couple practice ones. Maybe number 19, maybe number 5, or whatever you want. Do a practice with you, check with me.